start by marking the beginning of each measure of this rhythm with a bump of the hip. For the musicians among you, there is a popular Middle Eastern rhythm called a Baladi. It's in 4/4 time and follows the pattern doom-doom, tek-doom, doom-doom, tek-doom. So we're marking out this rhythm with a ratio of 1 hip bump per measure. Now let's increase our number of hip bumps to 2 per measure. So you can say we've divided this measure of music into 2 pieces, with each hip bump marking out half of the measure. Now that we've got 2 hip bumps per measure, you've probably noticed that the amount of time between each hip bump has been cut in half. What if we divide this measure further? How about into 3? How about into 4? Again, you'll notice that the more hip bumps we fit into each measure, the time between each bump becomes smaller. Can we increase our number of bumps per measure? Let's go to 6, 8. As you can see, we can keep increasing our number of bumps per measure of this rhythm, and as we do, we divide the measure into smaller and faster pieces. Is there a limit to how many pieces we can divide this rhythm into? 12? 16? We can always go higher. No matter how many bumps we can fit into a measure, we can always squeeze in one more. The possibilities are infinite. You can say that as our number of hip bumps approaches infinity, the amount of time between each bump becomes smaller and smaller until it is almost nothing. So the time between each bump is never quite 0, but it gets pretty close. If we graph this as y equals 1 over x, where y is the amount of time between hip bumps and x is the number of hip bumps we squeeze into a measure, y is never quite 0, but it gets pretty close. And this 0 that we never quite reach, but get closer and closer to as we approach infinity, is our asymptote.